Today's question comes to us from the 2018 Chemistry Paper 1 Foundation Tier, and it's question 7. And this is all about the soluble salts practical. So we've got here, a student plans a method to prepare pure crystals of copper sulfate. I'm just going to underline that because the precise chemical that we want to make is important for what chemicals we're going to use. The student's method is that they add 1 spatula of calcium carbonate to dilute hydrochloric acid in a beaker. When the fizzing stops, heat the solution with a Bunsen burner until all liquid is gone. This method contains several errors and does not produce copper sulfate crystals. Explain. So that means we want to say why. The improvements the students should make to the method so that pure crystals of copper sulfate are produced. So weirdly, I'm going to answer this in a way which I think is important for your revision. It wouldn't necessarily be how I would answer it if I was short on time, but let's consider the perfect method and let's see where the student has disagreed. When we do a method, we can think about it like a recipe, and when we think about it like a recipe, that to me means clear steps, and if you want to use a diagram, you use a diagram. So the soluble salts practical involves us taking some acid. We can warm it gently on a Bunsen burner. Use an arrow for heat. We then take it off. We add our insoluble base and stir it until we see some unreactive stuff at the bottom. We then filter it, evaporate as much water as we can, but we still want some liquid. And then we use an evaporating basin to finally slowly evaporate and get us crystals. Let's put that together in the method. Now I'm just going to draw a line down here. So on this side, we're going to think about where they've gone wrong. If I'm making copper sulfate, we need to be specific. And when we talk about the steps, I want to be specific. Talk about amounts, talk about masses, talk about volumes, talk about what chemicals. If I'm making copper sulfate, our base has got to contain the copper, and the acid is going to be our source of the sulfate, sulfuric acid. So this is going to be sulfuric acid, and our powder here, well, they use carbonate, but they've used calcium carbonate, a bit of a spoiler for the future. We're going to use copper carbonate. Step 1, gently warm, and again, let's be specific with our volumes, 25 centimetres cubed of sulfuric acid. Step 2, we add the copper carbonate and stir until no more copper carbonate reacts, and we have unreacted solid at the bottom. So that's our step 1, that's our step 2. And now we're going to filter it to remove that undissolved solid. To now make the crystals, we boil off the water until a small amount of liquid remains. We do that until a small amount of liquid remains. Another way of saying that is until some crystals start to appear. And then step 5 is leave to slowly evaporate and crystallize. We've used this question to recall the method of this required practical. So let's now actually answer where this student has gone wrong. First thing is they didn't warm the acid, but also you'll notice they used hydrochloric acid, which is stupid because that would make a chloride. Next thing that they did, okay, in their method is they used calcium carbonate. We want copper if we want copper sulfate. And the next mistake is they actually only add 1 spatula. We've got to keep at it until no more reacts. And this is important, so all of the acid involved has reacted. Next mistake, they didn't filter it. And the problem you've got there is you've then got this unreacted carbonate in your crystals. And finally, they rushed this. They've done heat the solution until all the liquid is gone. You're going to get a powder. The best crystals, you've got to make sure it's slowly. You can actually also do a process called recrystallization, where after you've done it all, you redissolve a little bit in the minimum amount of liquid and finally drive it off. There we have it, a good way of revising our salts practical and then linking it back to the question. This is probably overkill for an exam question, but I'm sure you can see why I did it this way, because it enables us that little bit of extra revision.